This is Module 9, Section 3.4. In this section, we're going to look at the definition of slope, counting slope from a graph, vertical and horizontal slopes, and the slope formula. Slope is simply the slant or the steepness of a line. So our question becomes, in this section, how does slope measure the slant of a line? There are many definitions of slope. We're going to introduce all of them in this introduction, and then we're going to use a couple of them as we do problems as we go through this section of Module 9. Slope almost certainly was first defined for you as the rise of a line over the run of a line. What that means in terms of an XY axis, if you think about rise over run, rise is always the change in your Y values, rise is always vertical movement, and run is always horizontal movement or change in X values, since your X-axis, of course, is your left-right movement and your Y-axis is your up-down movement. So X is associated with run, Y is associated with rise. There's a symbol for the phrase change in science and math, and that's the Greek symbol delta. So you may see change in Y divided by change in X written as delta Y over delta X, where delta simply means the phrase change in. Anytime you're looking at a change in something, whether a change in temperature as the day goes on or a change in the height of a person from one year to the next, you can measure that change using subtraction. It's a difference. For example, if the temperature on a certain day started at 5 degrees and by the end of the day it was 35 degrees, the change in temperature would be 35 minus 5, which is 30 degrees total. So it is a subtraction problem. So change in Y can be expressed as Y2 minus Y1 divided by X2 minus X1. And in general, slope is given a symbol in math as a lowercase script m. So anytime you see a lowercase script m, that almost always is indicating the slope of your line. So the first thing we're going to do is we're going to learn how to count slope from a graph. There are several ways to determine the slope of a line, as we saw in the previous slide. One of those ways is to graph the line on a coordinate system and count the number of units we change both horizontally, which is X movement, and vertically, which is Y movement, as we move along the line, and we're going to express that as a ratio. Horizontal movement is always change in X values. This is also referred to as the run of a line. If you move right on an XY coordinate system, you know that the value is always a positive number, because remember, the X-axis is simply a number line, and you know that anytime you have a number line and you're moving to the right, your numbers are getting larger. So you've got positive movement if you move right along the X-axis. And as you move left, the value is negative because you are decreasing your numbers. Vertical movement is always change in Y values. You know that the Y-axis, again, is simply a number line, whereas you move up, you're getting more and more positive, and as you move down, you're getting smaller or more negative. If you move up, the value is a positive number, and as you move down, the value is a negative number. So here are the instructions to count slope from a graph. Your first step is to pick 2 points on the line that you're trying to find the slope of. Make sure the points lie on a crosshair on the graph so you're accurate in counting slope from that point. You don't want to pick a point that is not directly on a crosshair. Your second step is to draw a right triangle connecting the 2 points. A right triangle is a triangle that has a right angle or a 90-degree angle, or another way to say that is the legs that form that angle are perpendicular. Next step. Choose one of the 2 points to begin at. It doesn't matter which point you choose, and you're going to travel along the line to see how those values change as you move along the line. So choose 2 points with 1 point to begin at. Your fourth step is to trace the horizontal leg, which is the run value of the triangle you drew, counting the units as you trace, and noting the direction you are moving. Remember, for your horizontal movement, if you move right, you've got a positive change, and if you move left, you've got a negative change. Step 5, trace the vertical leg, or the rise value of the triangle you drew, counting the units as you trace and noting the direction you are moving. Remember that if you move up, it's a positive rise, and if you move down, it's a negative rise. Now I want to stop here just for a minute. Note that, depending on which point you decide to start at, you might in fact find it easier to count the vertical leg first and then the horizontal leg. So steps 4 and 5 can be interchanged if you need to, if it makes more sense with how you're tracing your line. Your sixth and final step is to divide your rise by your run, because the definition of slope is rise divided by run. Okay, so let's do some examples. Find the slope of the line given in the graph below by counting the slope on the graph. All right, now your first step is you want to look at that line and as best you can pick 2 points on that line that look to go directly through a crosshair on your graph, because that's going to allow you to count your slope. So the values I picked, it looks to me like this point right here goes directly through a crosshair. And just for reference sake, I'm going to label that point. This really isn't necessary, but just so you can see what point I'm at. That's at -6, or 6 to the left and 3 up. -6, 3. And then another point that looks like it goes directly through a crosshair is this point right here. And that is 4 to the right and 4 down. Okay, so after you pick your 2 points, then you want to take those 2 points and draw a right triangle to connect the dots. Now there's a couple of ways you can do that. One is you could move off to the right until you get to x equals 4, and then you could move down. You'll notice that you've got a right triangle there because this forms a 90-degree angle. Another option, if you wanted to, is you could trace along the bottom of the line. You could go down until you get to -4, pretend like that's straight, and then over to get to the point there. Okay? And you can move in either direction. So let me give you an example here. Let's say you decided to go with that red line, and you decided to start at this point to the left, just because that's what you picked. And you decided to trace along that red line to get to that second point, which is down in the lower right-hand corner. So if you trace from this point to this point, you would go right to this, and then you'd go down to the lower right-hand corner. So count as you go. If we're moving in this direction, we would move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units. And since we move to the right, that's a positive 10 in terms of horizontal movement. So that's a positive 10 x movements, or a positive 10 is our run. Run is always horizontal movement. From that point then, we're going to move down. So we're going to move, count as you go, 1, 2, 3, 4, 5, 6, 7. 7 units down. 7 down means a -7, because down is negative and up is positive, and that represents your run. The definition of slope is rise over run, And so the slope of this line, if that's how we decided to count it, would be the rise value, which is -7, over the run value, which is a +10. That gives us a fraction. Ask yourself, can I reduce that? The answer is no. Therefore, that's your answer. So let's say instead you drew your triangle like this blue line. But again, you decided to start at the left and move to the right. So you decided to move down first, and then from that point move right until you got to your ending point. So let's count that and see if we get the same slope. If you move from this point and move down and count, you've got 1, 2, 3, 4, 5, 6, 7 down. 7 down means -7, and again, that's still your rise. Vertical movement is rise. Then from there, we're going to move right. So from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We move 10 to the right. 10 to the right is +10. And so that is your run. And again, slope is always rise over run. Notice we got the same values. We got -7 over 10. Same answer, and therefore same slope. What if you moved in the opposite direction? Let me pick another color. Let's say you decided to start in the lower right and decided to go to the upper left. Now if you did that, and I'm going to trace the red line as an example, you would have to go up and then you would go right. Okay? Now that direction is different, so those initial numbers are going to be different. Let's see how that works out in the end. So starting at this point right here, if you move up and count, you've got 1, 2, 3, 4, 5, 6, 7 up. Okay? 7 up is a +7. That's your rise. And then you'd have to move left to get over to that left point. So you'd move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 to the left is -10. That's your run. But when you put it in the slope formula, slope, again, is rise over run. Your rise now, and we're looking at the green numbers because we counted from right to left, your rise now is a +7. Your run is a -10. But -7 over 10 and 7 over -10 are exactly the same. Both of them are negative fractions. In either case, you could just pull the negative out in front if you wanted to, and you have the same value. So it doesn't matter which point you choose to start at. It doesn't really matter what direction you move as long as you keep track of the sign of both your vertical and your horizontal movement. All right, so let's look at this example. Find the slope of this line by counting the slope. Again, your first step is to find points that look like they go directly through crosshairs. And I think on this graph, this point right here looks like a good point. That happens to be -1, 0. Okay? And it looks like this point right here also goes directly through a crosshair. That is -3, -2. But again, you don't really need those labeled. What you do need, though, is a right triangle drawn. So I'm going to go ahead and draw this triangle right here. And I'm going to move in the direction that I just drew it. So I'm going to go from left to right, starting at this point right here. I would go up 2. Okay? Up 2 means a +2 Y movement. That's rise. Then from there I'm going to move to the right. Also 1, 2. Right 2 is +2 as well, but now that's your run value. So put that all together. Slope is equal to rise over run, which in this case is a +2 over a +2, which simplifies down to a +1, and that's your slope. All right, let's look at this line here. Pick any 2 points that it seems to you like go through a crosshair. Looks to me like this point right here goes through a crosshair nicely. And this point here looks pretty good too. Okay? If you want to label those points, that would be -6, 6 to the left and 1 up. And this point down here, it looks like we went 7 to the right and we're 2 down. All right, draw your triangle. I'm going to choose to draw it on the bottom side here. Okay, so there's my triangle. And I'm going to move in that direction as well. So I'm going to go down first, and if I count 1, 2, 3, I went down 3. Down 3 is -3. And then from there, I'm going to move to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I moved right 13. Right 13 is a positive 13. Left-right movement is your run. Up-down movement is your rise. And so your slope, which as always is rise over run, is going to be -3 over 13, which can't be reduced, and so that's your final answer, -3/13. All right. Let's look at this line here. Find the slope of the given line by counting the slope. Find 2 good-looking points that you want to look at that go through a crosshair. One of them looks like this is a good point. This is -2, 1. And a second point looks to be right here. That's 5, 3. Draw yourself a right triangle. I'm going to go to the right and then up. So here, right means positive, and I'm going to count 1, 2, 3, 4, 5, 6, 7. That's a positive 7. That's my run. From there, then I have to move up. So from here, I'm going to go up 1, 2. Up 2 is also a positive value. That's my rise. And if we put it together, slope is equal to rise over run, which in this case is a +2 over a +7. Okay, now here we have a vertical line. So we're going to count slope on this vertical line. Now that line should be directly on x equals 3. It did end up looking like it was shifted over a little bit, but that should be directly on x equals 3. So we've got our ordered pairs here. You can label them if you want. You've got, in this case, 3 to the right and 0 up or down. This point over here is 3 to the right, and it looks like 3 up. Okay, now you can't really draw a triangle because there is no left or right or horizontal movement. There's only vertical movement. So in this case, you agree with me that if you're going from your lower point to your upper point and you're counting, you go up 1, 2, 3. So up 3 is equivalent to a +3 rise. But when you go from the lower point to the upper point, you don't move left or right at all. So you have 0 left or right. And so therefore, you have 0 equaling your run, because you don't move left or right at all. So slope is equal to rise over run. Our rise is a +3. Our run is 0. And the problem here is, with fraction work, anything divided by 0, you know, is undefined. So there is a slope of a straight line whose slope is undefined. It happens to be a vertical line. All right, let's look at the other special case. Let's look at a horizontal line. If you're using slope equals rise over run, and you pick 2 likely points on your horizontal line, I'll just pick these 2. Okay. This point right here is sorry, that's not right. It's 0, -4. And this point right here is 3 to the right and 4 down. And again, you can't draw a triangle because you don't have any angle to that line, but you can still trace from one point to the next. In this case, the way to trace from one point to the next is you're going to move right 1, 2, 3, right 3. Right 3 means positive 3 in terms of run. But then vertical movement, there is no vertical movement. There is no rise. You move 0 up or down. And therefore 0 represents your rise. Put that into your equation, rise over run. Now we have 0 over a run of positive 3. Now, unlike the previous case, 0 divided by anything except 0 is just 0. Therefore, the slope of a horizontal line is 0. Slope of a vertical line was undefined. Okay, so from all those previous examples, we can now make generalizations about slope. For lines that are neither horizontal nor vertical, as you look at lines and you trace them left to right, for example, here if I was to trace this line left to right, lines that go up or rise as you trace them left to right will always have a positive number as a slope. Might be a positive 2, might be a positive 1/2, might be a positive 9, but it will be a positive number if it goes uphill or rises as you trace it left to right. If you have a line that as you trace it goes down or falls, as you trace them left to right, then those lines will always have a negative value associated with their slope. And if you look at the examples we did prior to this, you'll see that that was true. The two special cases, we already found out what kind of slope they have. Horizontal lines that do not change as you trace them left to right have a slope of 0. In other words, if you think about it in terms of lines increasing or decreasing, rising or falling, you would agree with me that a horizontal line, as you trace it left to right, doesn't change at all, either going up or going down. So there is no slant or steepness to the line, therefore the slope of a horizontal line is said to be 0. Vertical lines, on the other hand, as you trace them, you would agree with me that you can't get any steeper than straight up or down. Okay? That's like infinite steepness. Vertical lines have infinite slope as you trace them left to right. That is, you cannot get any steeper than vertical. Since there is not a number to represent infinity, the slope is said to be undefined. A lot of times people think that infinity is actually a number, but infinity is not a number. It's a symbol to represent continuation. So you can't say that slope is infinity because then somebody could say, well, there's always infinity plus 1. So, slope of a vertical line is undefined. Now let's think about the math involved with counting slope of a line. To count slope, you first pick 2 points on the line and draw your triangle. These points can be represented with 2 ordered pairs. We're going to call the first ordered pair x sub 1, y sub 1, and the second point x sub 2, y sub 2. So it's just 2 points on the line and we're going to give them labels. The rise of the line, which is the vertical movement, is simply how the y values change from one point to the next point. This can be expressed as a difference. It's a subtraction problem of the y values. So if you have 2 points and you know the y values for each, if you subtract the 2, that's going to give you the rise of your line. It's simply a difference. In a similar fashion, the run of the line or horizontal movement is simply how the x values change from one point to the other point. This can be also expressed as a difference or subtraction problem of the x values, x2 minus x1. Now note that the order has to be the same. If you're going to subtract y2 minus y1, then you have to subtract x2 minus x1. You can't flip those points around because you're tracing from one point to another, so the difference has to be in the same order. Since slope equals rise over run, slope can therefore be expressed as rise over run being expressed with y2 minus y1, which we just said is the same as rise, and x2 minus x1 being the same as run. So if you know any 2 points on a line, you can calculate the slope using the slope formula above. The advantage to that is you no longer need to have a graph to find the slope. So for example, let's say I asked you to find the slope of the line that passes through the points 2, -3, and -4, 5. Now, could you plot those points and draw a line through them and then count the slope as we were doing in the previous examples? The answer is yes, you could, but that's just that much more work because you'd have to have graph paper, you'd have to plot the points, you'd have to have a straight edge to draw the line because it has to be accurate to count the slope. If you know the slope formula, though, and you have 2 points on the line, you don't need a graph. All you need to know is that slope is equal to y2 minus y1 divided by x2 minus x1. So take your points. Let one of the points be x sub 1, y sub 1. It doesn't matter which one. If you want to let -4, 5 be x1, y1, that's fine. Let the other point be x2, y2, and then plug the corresponding values into the formula. In this case, y2 minus y1, as I have it labeled, would be y2 is 5, y1 is -3, so we've got y2 minus y1 would be 5 minus -3, over x2 minus x1 would be -4 minus 2. Now it's simply a matter of doing the math. 5 minus a -3 is the same as taking 5 plus a +3. Double negative is a positive. 5 plus 3, of course, is 8. -4 minus 2 is the same as -4 plus a -2, if you like that better. -4 and -2 is -6. Now that's a fraction. You would have to reduce that. There's a common factor there of 2. So if you divided 2 top and bottom, okay, we're reducing fractions, you would get 4 over -3. So the slope of the line that passes through those 2 points is -4/3. Let's do another example. Find the slope of the line that passes through the points 6, -1, and -4, -10. Again, if you have 2 points, you do not need a graph. You just need to know the slope formula. y2 minus y1 divided by x2 minus x1. Let one of those points be your x1, y1 point. Let the other point be x2, y2, and plug the numbers in. As I have it labeled, you've got y2 minus y1 is -10 minus -1 divided by x2 minus x1 is -4 minus 6. Do the math. Minus a negative up top is the same as adding a positive, so -10 plus 1 is -9. Here again, -4 minus 6 is the same as -4 plus a -6, which gives you -10. Now here, negative divided by negative is positive, and it's always better to put positive rather than negative if given a choice. So negative divided by negative gives you a final answer of positive 9/10 for your slope. Okay, let's do this example. Find the slope of the line that passes through the points -3, 4 and -4, 4. Again, let one of the points be x1, y1. Let the other point be x2, y2. Put it in the slope formula. Slope is equal to y2 minus y1, which, as I have it labeled, would be 4 minus 4. x2 minus x1 would be negative 4 minus negative 3. Do the math. 4 minus 4 is 0. Negative 4 minus a negative 3. Remember, minus a negative is the same as adding a positive, or double negative is a positive. Negative 4 plus 3 is negative 1. And 0 divided by anything other than 0 is 0. So the slope of this particular line is 0, which means it's one of those special case lines. It would be a horizontal line. Okay. Let me show you that it doesn't matter if you let the left point be your first point and the right point be your second point, or vice versa. Let's say you did this problem and you decided you wanted to let this left point be x2, y2, and you wanted the right point to be x1, y1. Okay, so let's say you labeled them differently. Will you get the same slope? Let's try it. Okay, now our slope again is y2 minus y1 over x2 minus x1. Put your values in that I now have labeled in red because I flip-flopped my designation. Now y2 minus y1 is 4 minus 4. x2 minus x1 is negative 3 minus negative 4. Do the math. 4 minus 4 is 0. In your denominator, negative 3 minus a negative 4 is the same as negative 3 plus a positive 4. And negative 3 plus 4 is a positive 1. But as before, 0 divided by anything is 0. And so you do get the same slope regardless of which point you let be x1, y1 and which you let be x2, y2. All right, let's do this one. Find the slope of the line that passes through the points 3, 1 and 2, 6. Okay, let either one of those points be x1, y1. I just work left to right, but it's completely up to you. So your slope is going to be y2, which is 6, minus y1, which is 1, divided by x2, which is 2, minus x1, which is 3. Do the math. 6 minus 1 is 5, over 2 minus 3 is negative 1, and 5 divided by negative 1 is negative 5. Now let's look at the points negative 5, 3 and negative 5, 6. Again, I'm going to let one point be x1, y1, let the second point be x2, y2. Slope is y2 minus y1, or 6 minus 3, over x2 minus x1, which is negative 5 minus negative 5. Do the math. 6 minus 3 is 3. Negative 5 minus a negative is the same as plus a positive. So you've got negative 5 plus 5. Negative 5 plus 5 is 0. And here, anything divided by 0 is an undefined fraction. Therefore, the slope of this line, if we were to graph it, would be undefined, and therefore that makes it a vertical line. We know that that would graph as a vertical line if we chose to graph it. Of course, you can still use the slope formula even if you were given a graph. Okay? So this happens to be one of those lines that we did earlier where we found a couple of points and we counted slope. What we want to do now is we want to take that same line and we're going to use the slope formula to calculate the slope instead of count the slope. So I'm going to try to use the same points we did before. When we were counting slope, we picked this point right here, I believe, which is negative 6, 3. And we used this point down here, which is 4, negative 4. Okay? And just to remind you, when we counted slope, we drew our right triangle, and then as we traced it, we counted and noted direction. So if you go down first, you'd have 1, 2, 3, 4, 5, 6, 7. We went down 7, so that was a negative 7 on our rise. And then we went to the right from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right 10 means a positive 10 run. And when we counted slope, we found that slope was rise over run, which is negative 7 over 10. Okay, now we're going to use the slope formula. Slope formula says if you have 2 points on the line, which I do, and you find the difference of the y values and the difference of the x values, you should get the slope without having to count. So I'm going to let this point be x1, y1. I'm going to let this point over here be x2, y2. And I'm going to plug those values in. y2 minus y1 would be negative 4 minus 3. x2 minus x1 would be 4 minus negative 6. Negative 4 minus 3 is the same as negative 4 plus a negative 3. That's negative 7. 4 minus a negative 6 is the same as 4 plus a positive 6, and that's 10. Notice we get the same answer using the slope formula without having to count the slope. Now, a quick check of that might be this. Remember the trends we said. If you take this particular line and you trace it left to right, you would agree with me that that line is falling. A falling or a decreasing slope should have a negative value attached to it. And notice that it does. It is a negative slope. And so that makes sense. Okay, use the slope formula to find the slope of this line. Now again, before when we were given lines, we were counting slope. We were drawing our right triangle. Now this problem does not ask us to do that. This problem just wants us to use the slope formula. But you still have to find 2 points on the line that go through a crosshair that will allow you to put values into your slope formula. So I'm going to choose these points. I'm going to choose this point right here because it looks like it goes directly through a crosshair. This point right here is 8 to the left, so that's negative 8. And then from there you would go down negative 5. So 8 to the left and 5 down is that point. And then find another point that looks like it goes directly through a crosshair. This point looks good to me. That point there is 3 to the left, so that's negative 3. And then it's 1 up, so positive 1. Okay, we've got our 2 points. We can let one of those points be x1, y1. Let the second point be x2, y2. Put that into our slope formula. And see what we get. y2 minus y1, as I have it labeled, is negative 5 minus 1. And x2 minus x1, as I have it labeled, would be negative 8 minus negative 3. Okay, double negative is adding a positive. So negative 5 minus 1 is negative 6. Negative 8 plus 3, because I changed that double negative to a positive, is negative 5. And negative 6 divided by negative 5, negative divided by negative, is a positive 6/5. Does it make sense that it's a positive number? If you look at the line and as you trace it left to right, notice it does go up or it increases. If the line goes up or increases, it will have a positive slope, and it does. All right, let's look at this vertical line. Okay, we did an example where we counted slope on a vertical line. Now let's use the slope formula. Pick 2 points on the line. I'm going to pick these 2. And again, that vertical line should be directly on negative 4. It is a little off. All right, so assuming that that line is directly on that x equals negative 4 line, this ordered pair here is 4 to the left, or negative 4, and 0 up or down. This point right here is also 4 to the left, or negative 4, but it's 3 up as well. So take those points, let one of them be your first point, x1, y1. Let the other one be your second point, x2, y2. Plug that into your slope formula. Slope is equal to y2 minus y1, which would be 0 minus 3, divided by x2 minus x1, which is negative 4 minus negative 4. Do the math. 0 minus 3 is negative 3. Down here in your denominator, minus a negative is the same as adding a positive. So negative 4 plus 4 is 0, and anything divided by 0 is undefined. So the slope is undefined, which is what we said was always true for a vertical line. Vertical lines have undefined slope. All right, what about the other special case? You've got your horizontal line. Let's use the slope formula to calculate that slope. Pick any 2 points on your line. I'll just pick these two. This point right here is 3 to the right and 6 up. So positive 3, positive 6. The second point is 6 to the right and 6 up. So that's positive 6, positive 6. Let one of those points be x1, y1. Let the second point be x2, y2. Take your slope formula and plug in your numbers. y2 minus y1 would be 6 minus 6. x2 minus x1 would be 6 minus 3, which gives us 0 divided by 3, and 0 divided by anything except 0 is 0. So this line has a slope of 0. It is a horizontal line, and that's what we said before. Horizontal lines have a slope of 0. So, what if you are just given an equation? Can you still use the slope formula to find the slope of the line? The answer to that is yes. You just have to find two ordered pairs that are solutions and put those values in the slope formula. You do not need to graph the line. As long as you have 2 points, you don't need a graph. You have a formula. So let's look at an example. Find the slope of the line 2x plus 3y equals 6. If we can get 2 points on that line, two ordered pairs, just like if we were going to graph, although we're not going to graph. Okay? If you can find two ordered pairs on that line, you can take those two ordered pairs, you can put it in the slope formula, and you'll have your slope, no graphing needed. So, from previous sections, do you remember how to find 2 points on a line? Remember, all you do is you take your formula, 2x plus 3y equals 6, and you choose to let x be some value or y be some value, and then solve for the other. Okay? So I'm going to choose to let x be 0 to get my first point. Okay? I'm going to let x be 0. Simply because it makes the math easy. Let x be 0, solve for y. So we get 2 times 0 plus 3y equals 6. 2 times 0 is 0, so I can ignore it because 0 plus anything is itself. So now I've got 3y is equal to 6. And if I divide both sides by 3, I find y is equal to 2 when x is equal to 0. There's 1 point. Now I need a second point. So I'm going to, for my second point, decide to let y be 0. Remember, you can choose anything you want to start with and just solve for the other variable, and that will be a point on the line. So if y is equal to 0, then this equation becomes 2x plus 3 times 0 equals 6. 3 times 0 is 0. So 2x is equal to 6. Or if I solve for x, divide by 2, x is equal to 3 when y is equal to 0. All right, there's my two ordered pairs. What we're going to do with those is we're going to label them. Let one of those points be x1, y1. Let the other point be x2, y2. and then plug that into your slope formula. It doesn't matter which way you label it. y2 minus y1, as I have it labeled, would be 0 minus 2. x2 minus x1 would be 3 minus 0. And 0 minus 2 is negative 2. 3 minus 0 is 3. And our slope of that line is negative 2/3. All right, let's do this example. Find the slope of the line y equals 2/9 times x plus 3. Now again, in order to find the slope, you don't have to graph it. What we're going to do is we're going to get 2 points on that line from that equation and then plug it into our slope formula. So I'm going to make a table to keep track of my points. I need 2 of them. I'm going to start off by letting x be 0. Okay? If x is 0, then my equation becomes y equals 2/9 times 0 plus 3. Anything times 0 is 0, so this equation solves fairly rapidly. Y is equal to 3 when x is 0. Now I could let y be 0 as well, but because I can see that that equation is already solved for y, it would be easier just to pick an x value and I wouldn't have to move stuff around. I could just throw it in my calculator or do my math by hand if I picked an x, and I'd have y without moving anything around using algebra. So I'm going to choose to pick another x value. And I'm going to choose to let x be 9 in this example, because I can see from that fraction, if I take 2/9 and multiply that by 9, which is the same as 9 over 1, I can see that my 9s are going to cancel. Cross-cancel across multiplication. Now, cross-canceling, remember, means just that you're taking out a common factor. So 9 divided by 9 will leave you with 1. Here, 9 divided by 9 leaves you with 1 as well. So my equation becomes 2 times 1, or 2, over 1 times 1, which is 1, plus 3, which of course is simply 2 plus 3, or 5. So when x is 9, I find that y is 5. I can then use my slope formula. If I label one of those points x1, y1, and let the other point be x2, y2, and I know that slope is equal to y2 minus y1, or 5 minus 3, over x2 minus x1, which is 9 minus 0, I get a slope of 5 minus 3 is 2, 9 minus 0 is 9. I have a slope of positive 2/9. Okay, this example, find the slope of the line negative 5x plus y equals 10. Again, need a couple of points. So I'm going to let x be 0 to start off with. So I've got negative 5 times 0 plus y equals 10. Anything times 0 is 0. So y is equal to 10 when x is 0. Next, I'm going to let y be 0. So now I've got negative 5x plus 0 equals 10. That 0, of course, is gone. Negative 5x is equal to 10. Or if you divide both sides by negative 5, x is equal to 10 divided by negative 5 is negative 2. So when x is negative 2, y is 0 for that equation. Use your slope formula. Let one of those points be x1, y1. Let the other point be x2, y2. Plug those values in. y2 minus y1 would be 0 minus 10. x2 minus x1 is negative 2 minus 0. And we get negative 10 divided by negative 2. Negative divided by negative is a slope of positive 5. And this is the end of Module 9, Section 3.4 material. If You should now complete the homework for section 3.4 in My Math Lab, and when you have successfully completed the homework, proceed to the video for Module 9, section 3.5.